Welcome to the fifth video on integrating the environmental evaluation into the conservation planning process. In this video, we will review the assessment tools that need to be completed to evaluate resource concerns that could not be evaluated with the screening questions. In step 4, we will analyze the resource data. We will study the resource data and clearly define the existing natural resource conditions, including any limitations to their use and potentials. This step provides the information needed to determine resource concerns to be addressed and to formulate alternatives. The analyses clearly establish the cause and effect relationships and provide information about existing and future conditions. As we inventory and analyze resources, we use several methods. We use procedural methods where we use a procedure to evaluate resources, such as SVAP2, pasture condition scoring, and rangeland health assessment. We use predictive methods where we use a tool to predict present and future conditions. Russell II, WEPS, IET, and WinPST are predictive tools. We use observation methods where we visually observe conditions in the field. And we use deduction methods where we use reasoning to determine what condition results from certain actions. Some of the assessments have already been completed in the field. For soil erosion, concentrated flow erosion, we use the observation method to determine that gullies were present for screening, and the deduction method to determine that practices or managements were not in place to control those gullies for the assessment. For soil erosion, excessive bank erosion from streams, shorelines, or water conveyance channels, we use the observation method to determine that streams were present for screening, and the procedural method to determine that the bank condition score from SVAP2 did not meet the planning criteria for the assessment. Some resource concerns will require further, more detailed assessments that will need to be completed in the office. For soil erosion, sheet, rill, and wind erosion, we used the observation method to determine that the cover was not sufficient in the screening question, but we must run a predictive tool, Russell II and WEPS, or IET, to calculate the predicted soil erosion. For soil quality degradation, organic matter depletion, we used the observation method to determine that the cover was not sufficient in the screening question, but we must run a predictive tool, Russell II and WEPS, or IET, to calculate the predicted soil condition index, or SCI, which identifies the predictive trend, either positive or negative, of the soil's organic matter content. For water quality degradation, pesticides transported to surface and groundwaters, we will use a predictive tool, WinPST, to predict the expected pesticide risk hazards. Then we will use a deductive method to determine if techniques and practices that are being used will mitigate those risks. We will use the Integrated Erosion Tool, IET, to assess the soil erosion, sheet, and rill erosion concern, whose units are tons per acre per year, and we will answer the assessment question, is the water erosion rate less than or equal to T, the soil loss tolerance? And the soil erosion, wind erosion concern, whose units are tons per acre per year, and we will answer the assessment question, is the wind erosion rate less than or equal to T? We will also assess the soil quality degradation, organic matter depletion concern, assessed by a positive or negative soil condition index number between -1 and +1. And we will answer the assessment question, is the SCI greater than 0? And the inefficient energy use, farming, ranching practices, and field operations concern, whose units are fuel use gallons per acre per year. We have already answered the assessment question as false, so the concern is present, but IET can give us benchmark fuel use that we can use later to assess alternatives that we may develop. We select the 3 cropland fields within Customer Service Toolkit and open IET. We complete the IET runs for all 3 fields by first selecting the management of 2 years corn and 1 year of soybeans with conventional tillage on the Crops Operations pane. We then verify the soils information on the Soil Climate pane. We then enter the slope that was determined for each field during resource inventories and set the contouring value to 1% absolute row grade as determined in the field on the Slope Practice pane. There are no barriers to enter on the Region's Barriers pane. We run the simulation on the Run Simulation pane and save the results. Once the results for individual fields are saved, they are displayed on the Planning Summary pane. Let's take a closer look at the planning summary. Notice the benchmark conditions are documented for all 3 fields. The water and wind erosion rates, the SCI, and the total fuel use for the 3-year rotation is displayed for all the fields. Currently, there is not an option for printing this table from IET, but the planner can use a screen capture tool to copy this information as an image that can be pasted into a Word document that can be printed and saved in the client's case file. IET has a report option where a report for each field can be printed. Notice the applicable information for answering the assessment question is displayed on this report. A report should be generated for each field and placed in the client's case file for the benchmark conditions to document the current resource concerns. Also notice that the report displays the fuel use in gallons per acre per year, which is the average of the 20 gallons per acre over the 3-year rotation. Now to answer the assessment questions. For the soil erosion, sheet and rill erosion concern, is the water erosion rate less than or equal to T? From the IET report, the T value is 5 and the soil loss on field 1 is 8.3. Field 2 is 6.2 and field 3 is 9.9 tons per acre per year. The soil loss exceeds T on all the fields. For the soil erosion, wind erosion concern, is the wind erosion rate less than or equal to T? Again, the T value is 5. Soil loss on field 1 is basically 0. Field 2 is 0 and field 3 is 0 tons per acre per year. The soil loss is less than T on all fields. For the soil quality degradation, organic matter depletion concern, is the SCI greater than 0? The SCI on field 1 is negative 0.61. Field 2 is negative 0.44 and field 3 is negative 0.73. The SCI is less than 0 on all the fields. For the inefficient energy use, farming, ranching practices, and field operation concern, whose units are fuel use gallons per acre per year, we have already answered the assessment question as false, so the concern is present, but the benchmark fuel use is 20 gallons per acre for the 3-year rotation, or 6.7 gallons per acre per year. Let's document the assessment on our resource concern checklist. The assessment question for sheet and rill erosion, water erosion rate less than or equal to T, is false, and the concern is present. We check the false box and the resource concern box and document the fields where the concern occurs and document the rates for the individual fields. The assessment question for wind erosion rate less than or equal to T, is true and the concern is not present. We check the true box and document the rates for the individual fields. The assessment question for organic matter depletion, SCI is greater than 0, is false and the concern is present. We check the false box and the resource concern box and document the fields where the concern occurs and document the values for the individual fields. For our final unknown resource concern, water quality degradation, pesticides transported to surface and groundwaters, we need to answer the assessment question. Conservation practices and managements are in place to minimize surface waters and groundwater impacts. We will use the tool WinPST to answer that question. In WinPST, we select the soils on the farm and add them to the soils queue. Then we select the pesticides that the client uses. In this case, Mr. Smith told us that he uses atrazine on his corn, so we add that to the pesticide queue. We create the soil pesticide interaction report and print it to include in the case file. We review the hazard ratings, where we will determine the highest rating for the concerns of leaching, solution, and adsorbed. For water quality concerns related to pesticide leaching, solution runoff, and adsorbed runoff, WinPST must be used to evaluate potential hazards to humans and/or fish for each pesticide used. The human hazard represents the potential for chronic impacts to drinking water, and the fish hazard represents the potential for chronic impacts to fish and other aquatic species. Note that we should only consider the hazards and should not use the loss potential, which is also shown on the report. For leaching, the highest rating is H, which is high. Note that you should select the highest rating of all pesticides in all soils. For solution, the highest rating is also H, which is high. Again, note that you should select the highest rating of all pesticides in all soils. For adsorbed, the highest rating is L, which is low. Note that there is no WinPST rating for human hazard adsorbed, since human exposure to sediment is minimal. Using Agronomy Tech Note number 5, the minimum level of mitigation required for each resource concern is based on the final WinPST soil pesticide interaction hazard ratings. For low or very low hazards, no points are needed for mitigation. For intermediate hazards, 20 points are needed for mitigation. For high hazard, 40 points are needed for mitigation, and for extra high hazard, 60 points are needed for mitigation. In our case, the highest hazard for leaching was high, so 40 points are needed for mitigation. The highest hazard for solution was high, so 40 points are needed for mitigation. And the highest hazard for adsorbed was low, so no points are needed for mitigation. Mitigation requirements can be met with conservation practices as well as IPM techniques. Mr. Smith may be using some of those techniques currently, and those should be considered when evaluating the benchmark condition. Agronomy Technical Note number 5, Tables 1 and 2 list mitigation techniques and practices and the number of points that can be credited toward mitigation for each hazard. Mr. Smith told us he walks his fields to check to see if there are enough weeds to justify spraying, and he won't spray if there is rain or high winds forecasted, which would probably meet the criteria for application timing rain technique, which contributed 15 points to all hazards. The application timing wind technique, which contributes no points, and the monitoring and economic pest thresholds technique, which contributes 15 points to all hazards. In Mr. Smith's situation, he is probably currently using techniques that would contribute 30 points toward mitigating the pesticide risk, so we would consider that the benchmark condition. This table gives us a summary of the results to answer the assessment question. To recap, we have determined the highest hazard rating for each concern from WinPST. then determine the needed points for mitigation. We also determine the points for techniques that the client is currently using, and now we can determine that the points don't mitigate the hazards for leaching or solution. So the questioned conservation practices and managements are in place to minimize surface and groundwater impacts is false. Let's document the assessment on our resource concern checklist. The assessment question for the water quality degradation, pesticides transported to surface and groundwaters concern, conservation practices and managements are in place to minimize surface water and groundwater impacts is false, and the concern is present. We check the false box and the resource concern box and document the fields where the concern occurs, and document the current points compared to the needed points. So, the summary sheet of our resource concern checklist is complete, and we have identified the following resource concerns on the cropland: soil erosion, sheet and rill erosion; soil erosion, concentrated flow erosion, ephemeral gullies; soil erosion, concentrated flow erosion, classic gullies; soil erosion, excessive bank erosion from streams, shorelines, or water conveyance channels; soil quality degradation, compaction; soil quality degradation, organic matter depletion; water quality degradation, excess nutrients in surface and groundwaters; water quality degradation, pesticides transported to surface and groundwaters; degraded plant condition, undesirable plant productivity and health; degraded plant condition, excessive plant pest pressure; and inefficient energy use, farming, ranching practices, and field operations. We have not identified any resource concerns on the farmstead. At this time, since we have completed our resource inventory and have analyzed the resource data, there may be some other actions we need to take from information gathered in the field. Cultural resources may be present, and some evidence was observed in the field. A cultural resource evaluation, along with maps of the farm, should be sent to the cultural resource specialist for review and possible consultation with the State Historic Preservation Officer or affected Indian tribes. Now would be a good time to document in the assistance notes the results of the assessments, transmission of the cultural resource information, and the identified resource concerns. Pause the video to review the assistance notes in more detail. We have started to gather a lot of documents that need to be added to the case file, such as resource inventory maps, the completed resource concern checklist, IET reports for each field, the WinPST report and summary of current and required mitigation points, photographs that were taken in the field during resource inventories, copies of cultural resource information that was sent to the cultural resource specialist, and of course the assistance notes. That concludes this video. Our next action is to document the benchmark conditions on the Environmental Evaluation, or CPA 52.